you can see the outside coil here. The center part of it is missing some turns. I took the turns out of the center part of it, and basically the electrons are moving this way, and the electrons moving this way, and then the tail back there that hooks the two together and goes to an earth ground is where your amperage comes in. So whenever you take your amps and volts apart and you start bringing them back together, you get volts times amps equal watts. So that's your useful energy, and you do this as you go into the capacitor bank. So coulombs and watt seconds are all basically 1 coulomb, and 1 volt second is basically 1 volt at 1 amp at 1 second. So they're all the same thing. Sir?
Can I have a question? The neon transformer, is that solid state?
This one looks like it's solid state, but it performs as though it's not. Being solid state, I'm not quite sure what it would do to it, but I've used them, and for some reason they work. I don't quite know why the reason is, but I do know they still work. And this one looks like a solid state because that's 9,000 volt transformer, the small one that's there. See that? That's 9,000 volts right there. And if you look at the label on this thing, you're in for a surprise, because if they tell you that there's so many volts in and at so many amps and so many volts out at so many amps, it turns out that this device right here is an over-energy device very noticeably, because if you look at the information on the one that's down here, you're looking at the one that's on the floor. So if you take the numbers off of the thing, the volts in and the amps in and the volts out and the amps out, that little device has produced noticeably more energy than it had going into it. So it's already beginning to behave as an over-energy device. And they actually stamped it on the label. They don't say that it does that, but just the guys that are curious can find out for themselves if they want to. So. Hey, we're going to move up closer on some of the photographs now and take a little bit closer look at some of the components that are on the device that we were just looking at. There you go. Okay, I have no way of knowing what you're seeing out there because I'm blinded by the lights up here. I'm simply trying to stay out of your way, so if you're not seeing something, you need to let me know. No, this thing is kind of, it could be that these lights back here are messing things up, but we can't really turn those off because they're making a tape of this, and if they turn them off, you'll just have the voice and what's here, and there won't be any speaker. So, anyhow, let's see. There we go. Okay, you see the L1 coil here. It's 3-inch Baker-Williamson coil. It's had the 4 turns taken out of the center here, and they're made into a pigtail, which forms the the negative ground out, or the amperage end of the deal. On the ends here, they're coming off and going out and coming through. This is a series of very high voltage capacitors that are normally found in flyback transformer circuits and televisions. So we're into very high voltage on those diodes. And basically what they're doing is what the 2 diodes were doing in the other device. They're taking a sawtooth pattern and changing it into a flat pulsating DC at very high voltage. It's coming out of there, and there's 2 outs here. One is whipping around and coming across here to here, and then it's going to the output over here, which there's a coil system. You see a double coil system there, and it's going through this first coil system, and at that point it's smoothing it out is what it's doing. And then it's going on to the output block, which is back there. At that point, you're ready to go to the transformer. Okay, this wire here has very interesting characteristics. It's extremely high voltage wire. It has a thick layer of silicone over it, and then it's got another envelope over that on the outside that looks like clear plastic. But it has some of these wires that I use have over 80,000 volts breakdown on them. So, and the bottom one down here is the same type of wire, same manufacturer, but it's a different color. And what it does is basically pick up. It doesn't come over to the device here. It really stops on this end of the device and goes this way, and then it becomes the output on the negative side there. So you've got your very high potential one, and then you've got you've got two of them. And the sense of plus and minus, which you normally think of, you really don't want to think of it here. You want to say that one area is higher pressure electricity and another area is lower pressure. And since the electrons are in an awkward position, they will try to get back to ambient. And the process of getting back to ambient, they're going to be doing the things that you want them to do. It's just like water that rains on the side of a mountain. It's going to find its way back to the ocean. So once you get the energy balance working for you, then you're on your way. Okay. Let's see. Can we go back to the slide, or do I need to do it? There we go. Okay, we're looking at it from another angle, and you can very easily make these the complete system out of a 3-inch piece of PVC. The one that's on the inside here is a 2-inch OD PVC, and it's got the windings for the L1 coil on it, as you can see through it. And the reason for putting it on the slide deal is the fact that that becomes a tuning device. If your device is not properly tuned, which you can build it without taking any measurements or doing anything, simply by calculating the length of wire that's in the L1 coil and then taking 1/4 of that and measuring a piece of wire and then using that for your L1 coil. And you will be very close to the tune almost going into it without any capacitors or anything. But you're going to probably want to put at least a capacitor either on your L1 or your L2. It's much simpler to put it on the L1. But if you put it on both of them, of course you're kicking the voltage up in both cases. And it doesn't take, it takes high voltage capacitors, which are a little bit hard to come by. The ones that I have here were custom made for me by Cornell Dubier, and you won't be able to